Welcoming you all for this fourth session. In this session, we will see about shelling and handling. So, shelling is a crucial operation in post-harvest technology, particularly in the context of grain crops, where the seeds are enclosed within a protective covering such as husks, pods, or shells. So, shelling is the mechanical process of removing outer covering from seeds or grains, leaving behind the edible portion. And handling in post harvest technology refers to the various operations and practices involved in the transportation, movement, and manipulation of harvested crops from the field storage or packaging area or farm produces to the marketing area or any other processing area. In this, certain examples are shown: corn shelling, peas, peanuts, beans, groundnuts. There are different types of shellers are there. In this main sheller, so harvesting and disking of corn is done either manually or power operated. Disking of maize cobs is necessary for use on shellers, and the sheller consists of mild shell fins, and one edge of the fin is tapered. So the cob will be inserted in the sheller and it is given forward and backward twist or anti given anti-clockwise or clockwise strokes repeatedly, so that the tapered edges of the fins dig into the space between the rows of the grains in the cob, and the forward or backward stroke grains are released from the cob. So due to these operations, the maize will be or the corn will be separated from the cobs, and this one will be power operated. So the difference will be the power source will be electrically given to this one. Before that, hand operated will be by means of any human needs. So the power operator will have 30 to 36 diameter cylinder of 80 to 100 centimeter length. So the cob moves toward the end of the sheller from a feeding side, and during this process, grains are rubbed against this drum and passes through the material. So the concave clearance and cylinder speed can vary and adjusted as per the recommendation or as per the size of the corns. So this one will be Husker sheller for maize. So this was developed by Department of Farm Power and Machinery, PAU Ludhiana, Punjab Agriculture University, and this has developed for two types of maize, Disker cum thresher, namely spike tooth type and axial flow type. So for threshing the maize along with the husk. So in this there will be two operations will be takes place, threshing operations as well as shelling operations will be takes place, so that it requires a PTO shaft and a spike tooth type sheller. Pegs are staggered at varying heights for better shelling efficiency, and de-esking cum shelling saves a lot of labor in comparison to traditional system. And next one will be groundnut decorticator. So in this groundnut decorticator, there will be two types. One will be hand operated and another one will be motorized or mechanical operated. So in this hand operated, we have L angle frame and four legs. A perforated sheet of sieve in semicircular shape is provided, so that the groundnut parts are shelled between the oscillating sector and the perforated concave sieve. The kernels and husk are collected at the bottom of the unit. So the clearance between the concave and the oscillating sector is adjustable to decorticate the pods of different varieties of groundnuts. So the decortication is nothing but the removal or the breaking of outer cover of groundnut to get out to getting out the uh, peanuts inside of the shell. So this is nothing but the decortication, and this is nothing but the power operated decortications. It consists of a hopper, double crank lever mechanism, and an oscillating sector with a sieve bottom and a blower assembly. So because of this double lever crank mechanism, we can get much product, much output compared to a traditional method. So in this also the blower helps to separate the kernels from the husk, and the kernels are collected through the spout at the bottom. The shells are thrown away from the machine. So this is nothing but a groundnut decantator which is operated by electrical means. And caster seller is nothing but removal of caster seeds from the outer cover of the caster cell, and it consists of shelling drum which is operated by crank through a gear unit which sells the caster pods. Manual clearing is done. The unit is operated by two levers, and the capacity will be lower compared to power operated. So in this power operated we have cylinder and a concave and a feed hopper, blower, and an electrical motor. The electrical motor supplies power to the cylinder and concave where the caster seats or caster pods are placed for the shelling operations. So the partially shelled pods come out from the chute at the end of the middle sieve. So the perforations allow sand particles with seed to be sieved out of the thrust caster bean. So because by means of this operated by electrical power, the capacity will be much higher compared to manual operated, which is like 250 kg per hour. And after these products are shelled and graded and cleaned, the materials needs to be handled like transporting from one unit to another unit of processing area, or one area to another area for storage, or for marketing purposes. So this includes a number of operations that can be executed either by hand or mechanical means, or devices to convey material from one place to another to reduce the human drudgery. So this can deliver lighten the work of the human labor. The main objective of handling is nothing but minimize physical damage to crops during transportation and handling, prevent contamination and deterioration of the quality of the produce agriculture produces, and facilitate efficient and timely movement of crops. So the selection will be considered on various factors like characteristics of the materials being conveyed, and possibilities of use of gravity, so that we can reduce the power supply, and the stability of the conveyor, dead load of the conveyor, capacity, and spillage and pollution of the environment. These factors needs to be considered by selection of conveying systems. By means there are different types of conveyors like belt conveyors, screw, chain, bucket, and pneumatic conveyors. The first one will be chain conveyors. So sorry, the first one will be belt conveyors. The belt conveyor is an endless belt operation between two pulleys with its load supported on idlers. So for transporting bagged materials or V-shaped or some other enclosed shape for moving bulk grains are used. So it consists of a belt, drive mechanism, and end pulleys, idlers, loading and discharge devices. So these conveyors have a anti-friction bearing, therefore these have a high mechanical efficiencies. So compared to other types of horizontal conveying system, the initial cost of belt conveying system is competitive. For these reasons, belt conveyors are used to carry cranes in processing plants, and in this conveys, scraper plow or stripper at the end of the pulley may be used to discharge the products or producers from the belt. So the belt conveyor can be discharged at various locations by means of any movable tripper. So there are certain design considerations to be followed for belt conveyor. So the main considerations will be based on available space, horizontal conveying length, conveying lift, characteristics of the material to be conveyed, and capacity requirement. So on the basis of this overall requirement and information, certain design can be determined like belt conveyor, belt width, belt speed, diameter of the pulleys and idlers, and belt thickness. So these can be determined by means of considering those previous factors, and the belt speed will be recommended from 2.5 to 2.8 meter per second for transportation of grains. And the volumetric capacity can be calculated by means of this equation, like area of cross section into belt speed, and mass capacity can be calculated. So for transporting of grains from one place to another place, uh, there is a terminology called trough angle is takes place in the belt conveyor. So for paddy, uh, trough angle will be 20 degree and the surcharge angle will be 20 degree, and for many other gains also the 20 degree will be shooted. For common trough angles will be 30 and 45 degrees. So the trough and surcharge angle can be varied based on the form of grains we are transporting. Like if we are transporting bulk grains, the angle will be varied, and if you are transporting any bagged materials, the angle will be varied. And there is a belt conveying idlers are used to roll to support the belt conveyors. So there are three types of idlers will be used. One is flatbed idlers, troughing idlers with the 20 degree, and troughing idlers with 35 and 45 degree. So these are based on the properties of grains, or the characteristics of the grains we are transporting from one place to another place. So the idler spacing needs to be calculated correctly, so that the life can be prolonged, or we have a good belt life. Then next one will be screw conveyor. The screw conveyor is nothing but the shape, or it consists of a tubular or U-shaped trough in which a shaft with a spiral screw revolves, so that the products can be transported from one place to another place. The screw conveyor's driving mechanism is simpler and no tensioning device is required. Therefore, the initial cost of the conveyor is lower than any other conveyors with the same length and capacity. Uh, the screw conveyor is generally used to move grains horizontally, since it can also be used at any degree up to 90 degree. So but the capacity correspondingly reduced as per the inclination of the conveyance, because there will be much need of power supply, and because of the gravitational force the products can be comes down from topmost point to the feeding area. And this is the basic diagram of the screw conveyor. In this we have a shaft, screw, and pitch, screw diameter, and shaft diameter. So based on this pitch length, the amount of grains, or the quantity of grains transferred, can be varied. So during conveyance the kernels are also subjected to continuous friction with these tough walls. So these screw conveyors may be designed for clockwise or anti-clockwise rotation. The change in direction of rotation doesn't affect the capacity. To determine the conveyance capacity of the screw conveyor, the formula in this slide can be used. This formula contains the pitch, diameter of the shaft, diameter of the screw, and the rotation of the screw. So by means of this equation we can calculate the theoretical conveyance of the screw conveyor. And next one will be chain conveyors. So it refers to a category of conveyors used in various applications, having one or multiple standards of endless chains that run the entire length of the conveyor path. So these kind of conveyors can be seen in many dairy industry applications, like in packaging areas. We can see in this kind of chain conveyors. So next one will be bucket elevators. So bucket elevators consists of buckets attached to grains or belt that revolves around two pulleys at the top and the other one at the bottom. So it's an efficient device for the vertical conveyance of bulk grains. So there will be classified into two types. One is spaced bucket elevators and continuous bucket elevators. The spaced bucket elevators are further classified as centrifugal, positive discharge, marine leg, high speed elevators, and the continuous bucket elevators are classified as super bucket and internal discharge bucket elevators. So there are different components are used. housing legs, bucket elevators capacity maybe depends on bucket size, conveying speed, bucket design and spacing, the way of loading and unloading the bucket, and the carriage of bulk materials. So, due to these factors, the conveying efficiency may be varied, and the speed of the belt depends upon the head pulley speed. A properly designed bucket elevator driven at the correct speed will make a clean discharge. If the belt speed is too low, the discharge of the grains becomes more difficult, or if the speed is too high, the buckets are not fed well. So, to calculate the capacity of the bucket elevator or the conveyance efficiency or conveyance like convey capacity, the following formula can be used. So the main parts of the bucket elevators are elevator head and boot section, elevator legs, belts for bucket elevator and buckets. So these are some of the components used in the bucket elevators. The next one will be pneumatic conveying. So the pneumatic conveyor moves granular materials in a closed duct by a high velocity air stream. So the pneumatic conveying is a continuous and flexible transportation method. This is carried in a pipeline either by suction or blowing process stream, and the air velocities will be in the range of 15 to 30 meter per second if it is necessary for most of the bulk materials. So since this works based on the principle of suction or blowing process stream, we need a source of air blowing or suction means of feeding the product into a conveyor ducts and a cyclone or a receiving hopper for selection of the product. So there are three basic systems of conveying pneumatic conveying. So these are pressure or blowing system, suction or vacuum system, and a combined push pull or suck flow system. So there are certain positive pressure and negative pressures that takes place for separation of product particles from air. Air product separators are used. Cyclones are mostly used to collect the particles. Cyclone is a device which removes the bulk of the product particle from the conveying air stream by centrifugal force. So the volumetric flow rate of air depends on the necessary air velocity and pipe or duct size used in this system. So fans and blowers with high volumetric flow rates and low pressures to positive displacement compressors produced high speed producers are used. So this is the basic diagram of the pneumatic conveying systems. So this consists of positive pressure and negative pressure, or combinations of both will have takes place. So this is all about cleaning material handling and shelling and grading. So there are certain factors needs to be considered while designing shellers and handlers. So we will needs to be very careful while designing these systems. So thanks to all. We'll meet in the next session.